Hello everyone, this is Dr. Mary Bach reporting for J310 Fabulous. I'm going to talk to you a little bit about using numbers in your reporting and writing. Even if you don't consider yourself a numbers person, you are. You use numbers every day to pay rent, you might apply for financial aid, you need to know how long it takes to get to class, you need to know the price of gas and how to balance that out with what you want to go out to eat tonight. Your audience, similarly, lives in a world constrained by important numbers concerning money, resources, time, and distance. As a reporter, you will be confronted by numbers in all kinds of stories that you cover. Government budgets, of course, obviously use numbers, but sports coverage, business news, reporting on the economy, translating science news, conveying information about polls, the census, demographics, birth rates, death rates, all of these things require a certain amount of translation so that you and your audience understand what the numbers mean. And so you should have a basic working knowledge of math and the difference between arithmetic and proportional differences. You should understand basic statistics and terms like median, mean, and mode. You should know what it means to have a margin of error for a poll. You should be able to create a graph or infographic representation to help your audience understand numbers in context. Numbers are often used in terms of percentages or ratios, like a 3-to-1 chance that it's going to rain tomorrow. Sometimes it's important to understand the rate of change, that is, how fast something is changing today and how fast it might change tomorrow. You have to understand these things so that you can translate them to the audience. Associated Press style has rules for writing numbers. Generally, if the number is less than 10, write it out, but there are exceptions. For a person's age, for example. If you're talking about dimensions, such as a 3-by-5 foot table, or percentages, or certain measurements. Get to know your style book. And no matter what the number, if it starts a sentence, write it out as a word. If you're writing for broadcast, you want to round off numbers. Instead of 999, simply say nearly 1,000. Instead of 3.7%, in broadcast style, simply say nearly 4%. As you're typing up a script for yourself or a colleague, make sure to use capital letters for the words million and billion. Do not use the dollar symbol. Write out the word dollars. And if you have a long number, for example, you're describing the state budget, use hyphens so that the reader knows that it is 1,000-200- Okay, so what about polls? They can be fun ways to engage your audience about politics, community issues, or their favorite taco shop. But before reporting on a poll, it's your job to know a little bit about it. You need to know how the questions were asked, because a loaded question like, do you agree that all puppies should not be kicked? Well, those kinds of questions can lead to skewed results, and political campaigns often use these kinds of questions in order to push for a desired result. It's also important to know how many people were polled and what the margin of error is. If two candidates are running 49 to 51% and the margin of error is 3%, your poll doesn't tell you anything. It's a good idea to also know who was questioned. If 4 out of 5 dentists recommend a particular kind of gum, but they all have stock in that gum's company, that would skew the results. And finally, know how many people were interviewed, because if only 5 dentists were interviewed, that's not saying much. Fallacies are the results of improperly taking polls or interpreting them. A fallacy of the average can happen when a small part of the sample gives an extreme answer. So, for instance, in class, if most people got an 85 on a test, but 3 people out of 100 got 0, that would pull the average down, and it would look as though people didn't do very well. That's the fallacy of the outliers. The fallacy of the unknown base would be if we asked these 3 smokers what they think of the cigarette ban on campus, and then reported back that 100% of the people polled don't like the smoking ban. That's the fallacy of the unknown base, because it gets back to the question about who was polled. Finally, there's the fallacy of the inappropriate time frame. If you're going to talk about statistics from a survey about women's rights from 1960, those results might not accurately reflect the population today. Same goes for issues about immigration, sex education, or the environment. Just because it's in a scientific paper doesn't mean that the number is appropriate for your story. Understanding statistics is what allowed Nate Silver, who blogged for the New York Times in the 2012 election, to correctly call that election and the way the various states would be counted. Silver knew that a poll is not a poll and how the various fallacies can skew results. If you're reporting on science, psychology, or medicine, you're likely to come across research statistics often, and there are some questions that you should always ask. You want to know why scientists collected that data. What was the purpose of their study? You want to know the dates of data collection, and you want to know how the data were collected. Remember, research is done by human beings who have to interpret the data, and your audience needs your help in understanding the different way that data can be represented. Some statistical terms that are useful for you include mean, median, and mode. Mean is simply the average, and the median is the number that is exactly in the middle between the highest and the lowest numbers in that data set. The mode is the most frequent number in the data set. Recall that example about most people in the class having an 85 and only a few getting a 0, pulling down that average? Well, in this case, the mode would be 85, and the median, if everybody got an 85 and the other 3 got a 0, that median would be 42.5. That certainly doesn't accurately explain what's going on. It's important to know the difference between correlation and causation. Correlation is when something happens at the same time. Causation is much harder to scientifically prove because causation requires something to happen first and then something else to happen after. There has to be a temporal sequence in order to prove causation. But lots of things can be correlated without necessarily having a causal relationship. For instance, people who drink lots of coffee in some studies have been found to have a lot of heart attacks. However, coffee has not been proven to be the cause. So what could be going on? Well, people who drink lots of coffee are also these so-called type A people, like me, who punch the elevator button too many times thinking it's going to make the elevator go faster. Type A people are stressed out and often have more heart attacks. The common thread here is the type A person, not the coffee. When you're talking to scientists, it's important to keep in mind that science is a process. It asks questions, and scientists are trained to express doubts, even about their own findings. Science generally presents information in terms of likelihood, and scientists will be very precise, or attempt to be very precise when you interview them. But we, as journalists, tend to be generalists. We want to know the bottom line. Scientists will usually say, well, it depends. So a good way to help translate scientific advice to your audience is to often ask a scientist how they would advise a friend or loved one about, say, how much coffee to drink or whether or not to get a particular medical test. Don't be afraid to ask a scientist to simplify an answer for the average person in your interview. If you don't understand it, there's no way you can do a good job of helping your audience understand it. Science often reports results in terms of statistical significance. For instance, we cannot prove beyond any doubt at all that the sun's going to come up tomorrow. Now we know, based on millions of years, that the sun has been coming up because the Earth travels around the sun and because the Earth spins. So it's very likely, because the Earth spins, that the sun's going to come up tomorrow. But if we are going to be absolutely scientifically perfect about it, we have to present this in terms of a statistical significance. Now, this can cause confusion because when you're talking to scientists, they might hedge a little bit about whether or not the sun's going to come up tomorrow because it cannot be predicted as a statistical absolute. Do not confuse scientific care about making predictions with the idea that there's another side to the story. Think of it more in terms of whether or not there's reasonable doubt to reject a significant finding. The best way to help your audience understand numbers is to find a way to connect the numbers to the way people live using sensory information. This is a great way to help people understand. That's how we got the phrase bigger than a bread box. Once upon a time, everybody knew how big a bread box was. But now we can say something is taller than the average man, or weighs more than a Volkswagen, or that she ran as far as 5 football fields. All of these are ways to help people relate to the numbers that you are trying to communicate. Numbers need to be put into context. If you're talking about how much property taxes are going to go up, translate that into the average tax bill. Today's multimedia environment allows you to do very creative things with data that will help your audience understand the numbers. Some numbers Might even allow you to create an online game that helps your audience understand, for instance, a local budget or how changing traffic in one part of town will jam things up in another. The worst thing that you could do as a reporter is to avoid numbers and fear them. Your audience needs you to be a careful and creative interpreter. Numbers are not necessarily facts. They often require interpretation. So one of the best questions that you can ask when you're covering a debate about statistics, demographics, science, or the economy is, how did you arrive at that number?